Yeah, I think you're pointing out about probably the most important aspect of adopting cloud computing. It's not about technologies. It's about first applications and about how to evolve the way you run these applications and run your data centers in a way that's evolutionary. Multiple steps of evolution rather than disruptive revolutions, which is typically not productive and high risk for the enterprise. So as a result, from a platform computing point of view, with 18 years of experience working with enterprise, we have engineered the products such that it can help and make it easy for users to adopt this general approach of clusters, grids, and clouds in a step-by-step way. For example, you can deploy your new applications or migrate your existing application from some big Unix SMP servers to a commodity cluster. Still running in isolation is a cluster server rather than a big SMP Unix server. It dramatically reduces the cost because the Intel AMD chip-based servers from HP or NEC or Dell is so much cheaper, right? So that's the first step, right? But once you've done that, you may find that you have a number of these clusters running individual applications. Again, you are in a siloed environment. Lower cost silo, but still silo. Utilization may still be 10, 20%, very low. But then next step is you can combine these clusters together to form what we call enterprise grid or limited scope cloud. To share the resources, introduce policies so that each application service level are met, but when the application needs more resources, they can use a lot more resources in the pool, and then when they are not using the resources, other applications can take over, right? So that would be another step. Or they can set up a very simple cloud environment just for certain specific use cases or applications. For example, one popular first step for a cloud is to support a test and development environment where these resources are dynamically allocated, not just VM containers, but also the whole application environments, the whole stack, right? The application server, the libraries used by the applications, the connection of the interior applications for the test and development, because you need to replicate the application environment when you are doing testing and developing your software, right? So that automates the whole setup of these environments. That would be the first step for some users. For some other users, they may just set up an analytics cloud, meaning you may have SaaS software, or you may have your in-house software to do your manufacturing planning. For these applications, you can host them into a cloud so that some application you have may run on Windows servers, other on Linux servers, and then cloud can now dynamically provision the resources to run your applications with the same hardware. And over time, once you build this cloud with dynamic resources and self-service capabilities, you can expand more resources and put more application on it. So you grow your cloud, and you may choose to forward your workload to external data centers, say delivered by NTT. Right? So it's an evolution, and at any moment in time, an enterprise can be using multiple modes of operations of clusters and grid clouds, running different applications, but they can keep evolving from there. Yeah, I think we can help in the sense that when you look at a cloud computing environment, the whole idea is to pull all your resources, typically heterogeneous servers and storage, because there are different resources needed by different applications, to pull them together and share them. Therefore, about the worst thing that can happen about the cloud is that you end up having multiple heterogeneous, vendor-specific clouds. And next worst thing, just about as bad, you have a vendor-specific cloud. If you have a vendor-specific cloud, any vendor has its limitations. They may be a VM vendor, they may be a server vendor, they may be an enterprise management software vendor. Because they have this particular angle, they may constrain your ability to run as many applications in your shared cloud environment. Platform takes a very different approach. We are a specialist focused in just one layer of software for managing cloud. We do not provide any hardware. We do not provide any OS. You can choose whatever OS and hardware you use and change them anytime in any combination. We integrate and support all kinds of hypervisors. It's KVM, it's DAN, it's VMware, also it's Hyper-V, and also Solaris containers. So we strive in integrating and supporting heterogeneous resource environments, as well as supporting different applications in a general sense, just like a cloud operating system. This layer of software should be separate from other layers of IT stack, the resources, the application middleware, and then the applications themselves, so that you can have a generalized environment. That's why the company, when we started in 1992, we have already clear vision, realizing that our customers, enterprises, need to have a general purpose distributed computing platform. And the company is called Platform Computing. So therefore, in that sense, yes, we strive to enable the customers to have choices and help them commoditize every level of the stack, of the IT stack. And that's dramatically different from the client-server environment, where you get OS, you get hardware, you may get storage and interconnect from the same vendor, right? And then since you need to have different environments, you end up having different silos from different vendors. Cloud is about integration and horizontally scaling out to share resources, even with heterogeneous resources running different kinds of applications on demand with low cost and high utilization. We expect to have out-of-box integration with this service provider management environment. Therefore, they are features of our products, not separate products. And by configurations, our users will be able to dynamically flow their applications to Amazon EC2, because we integrate with Amazon's Virtual Private Cloud, VPC environment. Then the Amazon resources now become a natural extension of internal data center resources for the customers, while still enable the customers have a private cloud management experience. So cloud is defined not by the resources you use and where they are. Cloud is defined by the operating environment implemented using the management software that we provide. Yeah, this is an area where there have been quite some misconception in the market of, wow, if you have all these cores, you have all these servers, and you want to take advantage of them, that means the individual application you have to be totally rewritten and completely parallelized to make use of these resources. And that's a rare exception rather than a rule, in the sense that in most cases, we are supporting a workload that can run many instances of the same applications or process many concurrent requests from the web to take them with all these resources to have elastic capacity to serve the customers without any change to the applications themselves, right? So for example, if you have some data processing tasks, or you are analyzing your customers or serving web requests, many of these tasks or applications can be running concurrently, but each is just a sequential job. Could be a Java bean handling a web request, or could be a business analytics to crunch through a chunk of your data. But you can run 100 of these applications crunch through 100 segments of your data warehouse data to achieve parallel, but the application is not parallel. Your business process, the work you do, is running in parallel with many servers and cores, but application software itself do not need to be parallel. Now, in some rare situations where you want to achieve very low-level, scalable parallel, then you may use some parallel packages, such as message passing parallel package, or such as parallel SOA package, to enable you to do a very low-level parallelism of the individual application code you have.